What if everything you've ever been taught about the fundamental nature of the universe is just, well, backwards?
Right. I mean, completely upside down.
Yeah.
Yeah.
Like, what if space isn't an empty void at all? What if it's actually this rigid, invisible ocean of hydrogen?
And, what if the physical matter that you and I are made of, the stuff we think is so solid, isn't solid in the slightest?
Exactly. What if it's merely a series of temporary rhythmic bubbles popping and refilling in that ocean?
It really completely flips the script on reality.
It does.
We are so conditioned to view the universe as a blank canvas, right? A dark, passive theater where stars and planets just, happen to sit.
But the framework we're dissecting today suggests the theater itself is the primary actor.
Yeah, the stage is doing the heavy lifting.
And that brings us to the core of this deep dive. If you're joining us, we're looking at a theoretical framework published in 2026 called SDMT.
Right, which stands for Superfluid Dark Matter Thixotrope.
Authored by R. Dumont and the Cerebrum collaboration. And our mission today is to really unpack their central claim that the universe is entirely composed of, quote, thixotropic superfluid hydrogen.
Which is a lot of words. But it requires us to first acknowledge the deep fracture in modern physics.
Oh, the massive fracture.
Right. For nearly a century, we've operated with this increasingly bloated set of rules. I mean, general relativity perfectly maps the big stuff.
Gravity, planetary orbits, black holes.
Exactly. But it assumes space-time is continuous and smooth, like a sheet.
Yeah.
But then quantum mechanics maps the microscopic universe, subatomic particles, electromagnetism.
And that side demands that reality is discrete, like pixelated.
Right. They refuse to communicate. Those two frameworks just do not play nicely.
And sitting right between them is the standard model of particle physics, which, to be fair, is incredibly accurate.
Oh, it's the most successful theory we have experimentally.
Right, but mathematically, it's kind of messy.
It's very messy. It requires over 24 arbitrary parameters.
Just knobs that physicists have to turn until the equations match the experimental data.
Yeah, like the mass of an electron or the strength of the strong nuclear force.
None of those numbers emerge from a fundamental, geometric logic.
No, they're just measured in a lab, plugged into the math, and accepted as brute facts of nature.
And this is why we're doing this deep dive, because the SDMT framework attempts to strip all of that away.
All the tuning dials. Gone.
It proposes a parameter-free unification. So for you listening, that means no invisible dark energy fields just glued onto the equations.
Right. No arbitrary masses, just one continuous substance governed by a rigid underlying geometry and 3 unchangeable rules.
So let's start with that substance, because replacing the literal vacuum of space with something physical is a massive conceptual hurdle.
It's a huge leap for anyone.
The SDMT papers refer to it as the plenum. And, in classical philosophy, a plenum is the exact opposite of a vacuum.
Right. It implies that every singular coordinate of the universe is full.
Full. But they specified that it is full of hydrogen. And I think the immediate question is, why hydrogen?
Well, hydrogen is the primal building block, right? It's the simplest and most abundant elemental structure in the cosmos.
But Dumont and the Cerebrum collaboration aren't talking about hydrogen gas, are they? Not in a standard thermodynamic sense.
No. They're talking about hydrogen operating in a highly specialized quantum state, a superfluid.
Okay, let's break that down. A true superfluid possesses absolute zero viscosity.
Exactly zero. It can flow, spin, and transfer kinetic energy without losing anything to friction.
Which is crucial, right? Because that explains how celestial bodies can move through it.
Yeah, that's the usual pushback. People say, wait, if the universe is full of fluid, why don't planets drag?
Right. You'd naturally expect planets to create massive wake waves, eventually losing momentum and spiraling into their stars.
But a macroscopic object moving through a perfect superfluid, as long as it doesn't cross a specific critical velocity, experiences zero drag.
Wow.
The fluid simply parts and recombines seamlessly around it.
Okay, so that hydrodynamic perfection is key. But the model introduces a really important caveat with the word thixotropic.
Yes, the T in SDMT.
Right. A thixotropic fluid changes its structural state depending on the stress applied to it.
We really need a concrete mechanical analogy here because thixotropy is usually associated with things like dense colloidal suspensions or complex gels.
Like ketchup.
Yeah, ketchup is a great example. It sits rigidly in the bottle until you smack it, and then it suddenly flows.
Or like cornstarch and water.
Ooh,
Look.
right, exactly. Let's look at the microscopic mechanics of the plenum. Imagine the superfluid hydrogen atoms at rest.
Okay.
Their quantum spins phase lock. They form this incredibly dense, rigid macroscopic lattice.
So it's solid.
It isn't frozen like ice, but it is phase-locked. It possesses intense structural rigidity.
But when a localized shear stress is applied, like
Mm.
when energy moving through a specific region exceeds a certain threshold,
That phase lock temporarily shatters. The lattice fluidifies, allows the energy to pass, and then instantly snaps back into its rigid state once the stress dissipates.
that is so wild. It's almost like tectonic plates.
How so?
Well, they're locked together, solid and unyielding, storing up all this immense pressure.
Right.
But when the stress finally exceeds their friction threshold, they violently slip and slide past each other. They turn that rigid boundary into a fluid, dynamic fault line, just for a brief moment.
That is a great way to visualize it. Space itself has an underlying structural memory.
It isn't a passive trampoline bending under the weight of bowling balls, which is the classic general relativity metaphor everyone learns.
Yeah, the rubber sheet analogy. SDMT throws that out.
It's a rigid, thixotropic ocean that only yields when properly stimulated.
But the theory goes beyond just calling it an ocean. They actually map out the exact molecular geometry of this phase-locked state.
Right. The framework proposes that at the smallest conceivable scale, the plenum is discretized. It's a grid.
They define it as a 39-cubed golden cross fractal network.
Okay, let's unpack that.
Well, this is where the geometric rigidity of the theory first really shows itself. A continuous fluid might seem chaotic, but this thixotropic superfluid operates on a highly organized, lattice-like architecture.
And the numbers they use here are incredibly specific. 39 cubed.
Right.
So if you're picturing this, that's 39 nodes along the x-axis, 39 along the y, and 39 along the z.
Which yields 59,319 interconnected nodes, forming a localized structural unit.
59,319. And the papers note that the number 39 is derived from the number 13 multiplied by the 3 spatial dimensions.
Yeah, and they tie the number 13 directly to harmonic resonance.
Like music.
Exactly like music.
Yeah.
Specifically, the complete diatonic musical scale, including the octave.
Now, I know it might sound a bit abstract to connect spatial dimensions to musical scale.
It does sound a bit out there at first.
But both are fundamentally studies of wave mechanics and resonance, aren't they?
Precisely. The structure of the universe, in this view, is an acoustic framework.
So the distance between nodes, the way pressure waves propagate through the grid, it all operates on the same mathematical ratios that govern harmonic frequencies.
Yeah. But if we have this massive grid of 59,319 nodes, the obvious question is what happens at the edges?
Right. Does the grid just stop? Is there a wall?
And that leads us to the topology of the plenum. The network doesn't have hard edges in the traditional sense.
Because that would break the fluid dynamics.
Right. The entire golden cross structure connects back on itself non-orientably.
Okay, non-orientable surfaces always bend the mind a little bit.
They really do.
The classic example is the Mobius strip, for you listening. If you take a long strip of paper, give it a half twist, and take the ends together.
You've made a Mobius strip.
Yeah. And if you trace a line along it with a pen, you eventually cover both what used to be the inside and the outside without ever crossing an edge.
It collapses two surfaces into one continuous path.
Right. So SDMT takes that,
The SDMT model applies that exact concept, but in 3 dimensions.
resulting in a closed Klein-Bottle topology.
Exactly. A Klein bottle is a manifold with no definable inside or outside and no boundaries.
The fractal grid of the universe loops back through itself.
Yes.
So, just to summarize the foundation here before we look at how things actually move through it, we are not sitting in an empty void.
Far from it.
We are embedded in a pixelated, thixotropic, superfluid Klein bottle made of phase-locked hydrogen.
That sentence alone requires a total teardown of how we visualize reality.
It's massive. But the structural rigidity of that Klein bottle necessitates strict mathematical rules, doesn't it?
It has to, because if the grid is fundamentally fixed in its geometry, there must be absolute limits on how pressure, waves, and energy can scale and propagate through it.
Which allows us to dive into the 3 universal constants of the SDMT framework.
Right, this is where the parameter-free claim really gets put to the test.
Yeah, because if you're going to replace the 24 arbitrary parameters of the standard model, your replacements can't just be made up numbers.
No, they have to emerge organically from the geometry we just described.
So let's hit the first one, the scale thruster.
Represented by the Greek letter beta.
Right, and in the Dumont equations, beta is exactly equal to the square root of a 137.
Which comes out to approximately 11.653.
Now, anyone who has studied physics, even casually, will recognize the number 137.
Oh, absolutely.
The fine structure constant, usually denoted as alpha, it's roughly 1 over 137.
And it dictates the strength of the electromagnetic interaction.
It has driven physicists crazy for decades because it seems to be this pure, dimensionless number that just miraculously makes our universe hospitable to atomic structure.
Yeah, Richard Feynman famously referred to 137 as a magic number that comes to us with no understanding. He used to say that all good theoretical physicists put it up on their wall and just worry about it.
That's hilarious, but in traditional physics, we just measure it. We don't know why it's 137.
But in SDMT, 137 is a structural limit of the grid. It's mathematically derived.
So how does the 39 cubed grid generate exactly 137?
Well, we look at the maximal number of coupling states in the network.
Oh.
If you take the 39 nodes along each of the three principal spatial axes, that gives you 117 states.
Right, 39 times 3, 117.
Then the geometry of the Golden Cross yields 19 intersecting interior planes that bind those axes together.
Okay, so 117 plus 19, that's 136.
Finally, there is the single absolute center node where everything converges.
Plus 1, that equals precisely 137.
The magic vanishes. It's replaced by pure structural logic.
That is incredibly satisfying. So 137 isn't an arbitrary electromagnetic tuning dial.
No, it is the maximum geometric capacity for connection within the fundamental pixel of reality.
And beta, being the square root of 137, functions as a dilation factor.
Exactly. When a physical phenomenon needs to jump in scale, say, moving from the quantum fractal level up to the next harmonic level, it scales by a factor of 11.653.
It's literally the geometric step size of the universe.
Yeah, that structural shift is the key. The universe scales in discrete, predictable jumps determined by its own architecture.
But jumping from one scale to another takes work, right? Which brings us to the second universal constant, gamma.
Gamma, this is the temporal friction, or the intrinsic viscosity of the fluid.
Okay, let's get the math first. Gamma is derived from the golden ratio phi.
Right. It equals the square root of 5 divided by 13, which is approximately 0.172.
Wait, I need to stop you there.
Sure.
Earlier, we established that a true superfluid has 0 viscosity.
We did.
But now we're saying there's an intrinsic friction of 17.2%. How do those two concepts coexist without contradicting each other?
It's a great question. The superfluid has 0 viscosity when energy flows smoothly along a continuous harmonic path, meaning without changing scales or breaking the fixotropic lock.
Okay, so if you stay in the same path, 0 friction.
Right. But when you force the system to restructure, when a localized wave forces the fluid to change magnitude across that discrete 39-cubed network, the thixotropic nature resists. The fractal lattice has to temporarily unlock, transfer the energy, and relock.
And that unlocking and relocking process is not perfectly efficient.
Exactly. 17.2% of the energy is dissipated into the structural memory of the plenum.
It's the cost of doing business in the universe?
Basically, yeah. Gamma anchors this friction to the pentagonal symmetry inherent in the Golden Cross geometry.
And the implication of this mandatory energy loss is, honestly, one of the most elegant solutions in the entire framework.
I agree. It creates the arrow of time.
Yes. Let's talk about time, because in standard physics, time is notoriously reversible in the math.
Yeah, the equations for a planet orbiting a star or a particle colliding with another particle, they look identical whether time is running forward or backward.
So physicists have constantly debated why we experience a one-way flow of time. Like, why does a dropped coffee mug shatter, but the shards never spontaneously reassemble into a perfect mug?
The traditional answer relies on entropy and statistical probability. It's just highly improbable for the mug to reassemble.
But SDMT provides a mechanical answer.
Time only moves forward because of gamma.
Because 17.2% of the energy in any geometric state change is irrecoverably absorbed as structural friction.
By the thixotropic fluid, yes. You cannot run the tape backward because the fluid has permanently consumed a fraction of the kinetic energy to perform the structural transition.
That is, time isn't a fourth dimension we travel through. It is quite literally the physical friction of reality restructuring itself.
Time is friction.
If the vacuum were perfectly frictionless in all states, every physical reaction would happen infinitely fast, simultaneously, or just reverse itself endlessly.
Gamma imposes a sequence. It forces the universe to operate as a one-way street.
Which brings a profound sense of thermodynamic grounding to the theory.
It really grounds everything in mechanical reality.
So we have beta, the scale thruster, gamma, the friction. Now the third constant locks in the final piece of the geometry, phi sub c, the striction angle.
Right, the striction angle is defined as 55.17 degrees.
And the papers describe this as the equilibrium angle where thixotropic shear is 0.
Imagine the forces acting on the fluid lattice. You have structural tension trying to hold the lattice together and dynamic shear stresses trying to fluidify it.
It's a tug of war.
Exactly. The striction angle is the precise geometric orientation where these forces perfectly cancel out.
It's the natural resting posture of the universe's fabric.
And like gamma, it is derived entirely from pure geometry. It is the arctangent of the golden ratio conjugate,
Specifically the arctangent of the square root of 5 minus 1 over 2.
which gives you 55.17 degrees.
So 3 constants, beta, gamma, and phi sub c, all 3 derived from pure, unalterable geometric logic.
The golden ratio, the 39-cube network, and the constraints of a Klein bottle topology. No one is arbitrarily tuning these dials.
They just exist because the shape exists, but I have to bring up a biological connection here.
Ah, yes, the 55.17 degree angle.
That is something that demands attention for anyone listening. The striction angle of the entire cosmos, the resting posture of the infinite thixotropic ocean, is 55.17 degrees.
And the internal angle of a standard water molecule, the exact angle between the 2 hydrogen atoms bound to the oxygen atom, is 110.34 degrees.
And 55.17 is exactly half of 110.34.
Meaning a water molecule is a perfectly symmetrical mirror of the universal striction angle.
When placed into the plenum, the geometry of H2O perfectly aligns with the zero shear boundaries of the universal fluid.
It is mathematically coupled to the resting state of the cosmos.
We will definitely explore the implications of that later because it fundamentally alters how we view biological life.
It's a huge thread to pull on.
But for now, we have our stage set. We have a rigid, phase-locked grid of hydrogen, and we have the mathematical speed limits and friction rules governing it.
But if space is full, where does a proton come from? Where does an electron come from?
Right. If it's all just an ocean of hydrogen grid, how do we get actual physical matter?
Well, the standard model treats particles as fundamental excitations of disparate invisible fields. An electron field, a quark field.
SDMT replaces all of those fields with a single mechanical process called the jitterbug cycle.
I love that name.
It's very visual. It's an oscillation, a rhythmic dance of the thixotropic fluid.
We established earlier that the fluid can act rigidly until a stress exceeds its threshold.
So the jitterbug cycle must be a geometric shearing stress that hits that breaking point.
Exactly. It is a localized energetic pulse that exceeds the yield stress of the plenum.
And what happens when it breaks?
When that threshold is crossed, the phase-locked lattice violently fluidifies and withdraws from a specific microscopic region.
The fluid pushes outward, it vacates the center.
Dumont calls this the Mandelbrot phase.
Cavitation, like a high-speed propeller spinning underwater.
Yes. The blades move so fast that they literally rip the water apart, leaving a microscopic void, a bubble of extreme low pressure right in their wake.
That is precisely the hydrodynamic parallel. The Mandelbrot phase creates a topological cavity.
The internal pressure drops below the ambient baseline of the surrounding plenum.
And in mathematical terms, this event is defined by a Dirichlet boundary condition.
Right.
Let's clarify the Dirichlet condition for you listening. It defines the boundary by assigning it a fixed value.
In this case, the fluid forms a rigid wall around the cavity, maintaining a fixed state of negative relative pressure inside.
So it acts as a structural mold.
The Mandelbrot phase carves out a negative footprint in the fluid.
But nature, especially a highly pressurized universal superfluid, abhors a vacuum.
Oh, absolutely. The moment the fluid withdraws to create the cavity, the immense external pressure of the surrounding universal lattice fights back.
The fluid aggressively snaps back to fill the void it just created.
This is the second half of the cycle, the Julia phase.
A filling phase.
And this inward rush of fluid is no longer governed by a Dirichlet condition, but by a Newman boundary condition.
Okay, so a Newman condition doesn't define a fixed value at the boundary. It defines the derivative or the flux.
It dictates how fast the material is rushing across the boundary.
So the flux is proportional to the immense pressure gradient between the absolute void and the universal plenum.
You have this rhythmic oscillation. Mandelbrot creates the cavity, Dirichlet holds the mold.
Then Julia rushes in to fill it, governed by Newman flux dynamics.
Over and over again, incredibly fast. This is what matter actually is in the SDMT framework.
A particle is not a solid object.
Not at all. It is a localized pulsating pressure.
Well, and this simple mechanical process solves one of the most stubborn mysteries in physics.
The nature of antimatter.
Yes. the baryon asymmetry problem. The standard model treats antimatter as an entirely separate class of particles that just happen to have opposite charges to regular matter.
And it assumes both were created in equal amounts during the Big Bang, which leads to the massive problem of why our visible universe is dominated by matter.
Where did all the antimatter go?
If they existed as independent, opposing substances, they should have annihilated each other completely, leaving nothing but photons.
But Dumont completely redefines the ontology of antimatter here.
Antimatter is not an independent substance hiding somewhere in the universe.
No, it is simply the Julia phase.
It's the filling phase of the hydrodynamic cavity left by the Mandelbrot phase.
Matter and antimatter are just two halves of the exact same geometric heartbeat.
The void itself, the negative pressure cavity created by the Mandelbrot phase, acts as what we observe as matter.
And the violent rush of the surrounding hydrogen plenum returning to fill that void, the Julia phase acts as antimatter.
So to look for a galaxy made of antimatter is missing the point entirely.
It's like looking at an ocean wave and asking where the antitrough went.
Exactly. They cannot exist independently. They're mathematically locked together.
I think you have an analogy for the Dirichlet and Newman math using everyday objects.
Oh, right. Think of walking in wet sand on the beach.
Okay.
The Mandelbrot phase is your foot pressing down into the wet sand, leaving a footprint. That's the Dirichlet condition, the mold.
And the Julia phase.
That's the ocean water rushing in to fill the footprint,
Yeah.
driven by the Newman flux.
So antimatter is just the water sealing the shoe print.
Exactly. The authors prove this using discrete conformal reflection. The mathematical shape of the Julia filling phase is the harmonic conjugate, the exact mathematical ghost of the Mandelbrot cavity.
When you observe a particle in an accelerator, you aren't seeing a tiny billiard ball.
You are observing the aggregate macroscopic effect of a fluid emptying and filling a localized pocket at quantum speeds.
This finally gives quantum mechanics a physical ontology. I mean, for decades, we've had quantum wave functions that perfectly predict experimental outcomes. But when you ask a physicist, what exactly is waving?
The answer is usually a shrug or a vague reference to abstract probability fields.
Right, but SDMT says the thixotropic hydrogen is waving. It's physical hydrodynamics on a fractal grid.
And when you scale up this hydrodynamic reality, you answer the next massive question.
Gravity.
Right. If a single particle is just a microscopic pressure well filling and unfilling, what happens when you clump trillions of these pressure wells together?
Like when you build a moon or a star.
You get a macroscopic pressure gradient, which leads us to the SDMT explanation for gravity.
The framework refers to it as fractal acoustic gravity.
General relativity beautifully describes gravity as the curvature of space-time. Massive objects warp the fabric of the universe, and other objects simply follow the straightest path along that curved surface.
But Einstein's equations never explain the mechanical substance of space-time, nor how a mass physically induces that curvature.
SDMT provides the missing mechanical link.
Gravity is not a fundamental independent force. It doesn't reach out and pull things.
No, it is purely an emergent property of fluid dynamics.
Think back to the Mandelbrot-Julia oscillation. When the Julia phase rushes in to fill the cavity, it leaves a trace.
A microscopic deformation in the surrounding thixotropic lattice.
And when you aggregate billions of these continuous deformations, you lower the overall ambient pressure of the fluid surrounding the massive object.
And we know that fluid always flows from areas of high pressure to areas of low pressure.
So if a star is basically a massive cluster of rapid cavitation, it creates a massive low-pressure zone in the universal hydrogen.
The surrounding objects aren't being pulled by the star's gravity.
They are being hydrodynamically pushed toward the star by the higher pressure of the surrounding cosmos.
The curvature of space-time, what physicists write as the metric tensor Gris-Mounier, is literally just the mathematical trace left by the filling of these cavities.
Gravity is an acoustic pressure gradient.
And the propagation of these pressure waves through the grid is governed by an equation Dumont calls the L39 operator.
Okay, L39 is a fractal Laplacian operator. Let's break down what a Laplacian actually does, because it is crucial here.
In calculus, a Laplacian operator measures how a physical quantity, like heat or fluid pressure, dissipates or averages out over a specific space.
Like dropping a pebble in a pond.
Yes, the Laplacian helps describe how the ripples spread and equalize.
The L39 operator is a specialized version built specifically for the 39-cubed Golden Cross fractal network.
It mathematically dictates how these acoustic pressure ripples traverse the nodes of our pixelated universe.
And the beauty of this operator is how it naturally accounts for the phenomenon we currently call dark energy.
Standard cosmology relies heavily on dark energy to explain why the universe's expansion is accelerating.
They introduced a parameter called lambda, the cosmological constant, right into Einstein's equations.
It represents this mysterious, repulsive force driving galaxies apart. But no one has ever detected dark energy, nor can they explain its origin.
It basically functions primarily as a mathematical fudge factor to make the observed reality match the equations.
But SDMT doesn't need to invent a mysterious new field. They just follow the mechanics of the fluid.
Recall the constant gamma, the temporal friction of 17.2%.
Right. Whenever the L39 operator dictates a pressure wave moving across the grid, the fluid must restructure, and gamma dictates that some energy is dissipated as structural friction.
Over the immense scale of the cosmos, this constant friction generates a uniform residual background pressure across the entire plenum.
Like a baseline tension humming through the lattice.
Exactly. And when Dumont plugs the gamma damping term into the L39 Laplacian, that resulting uniform residual pressure perfectly matches the observed accelerating expansion of the universe.
Dark energy is not an invisible phantom force.
It is simply the natural thermodynamic exhaust of a thixotropic fluid functioning with friction.
It's the heat of the engine.
The elegance is undeniable. I mean, we've eliminated antimatter as a separate particle, and we've eliminated dark energy as a mysterious force.
Both are just mechanical features of the fluid.
But the L39 operator does something even more profound. It directly ties the physical stability of reality to the Riemann hypothesis.
Oh, this is where SDMT bridges the gap between pure mathematics and physical ontology in a way that is genuinely breathtaking.
The Riemann hypothesis is basically considered the holy grail of pure math.
Proposed in 1859, right?
It deals with the distribution of prime numbers. Specifically, it predicts that all non-trivial zeros of the Riemann zeta function will fall perfectly along a single vertical line on the complex plane known as the critical line.
It is a beautiful mathematical pattern, but typically pure math puzzles about prime numbers don't dictate physical reality.
They're just abstract. But Dumont's equations argue otherwise.
Right. When they calculated the eigenvalues of the L39 operator, which essentially means finding the natural resonant frequencies, or the standing acoustic waves allowed by the 39-cubed fractal grid,
They discovered a perfect alignment.
the eigenvalues of the plenum's structural vibrations match the imaginary parts of the zeros of the Riemann zeta function perfectly.
Wow. So the zeros of this 160-year-old math problem are the exact acoustic frequencies at which the universe vibrates.
They are the allowed resonant modes. Think of a guitar string.
Okay.
When you pluck it, it doesn't vibrate chaotically. It settles into specific standing waves or harmonics dictated by the length of the string.
The Riemann zeros represent the geometric frets of the universal Klein bottle.
And the necessity of the Riemann hypothesis being true becomes a matter of physical survival.
Because if a zero fell off the critical line, it wouldn't just be a math error on a chalkboard.
No. If the Riemann hypothesis were false, if a non-trivial zero deviated from the critical line, the math demonstrates that the corresponding resonant frequency wouldn't form a stable standing wave.
It would induce an exponential, undamped perturbation in the thixotropic fluid.
It would trigger a Lyapunov instability, a runaway feedback loop of chaotic pressure.
The universe would physically tear itself apart.
The rigid lattice would dissolve into total chaos. The Riemann hypothesis isn't just an abstract curiosity.
It is the mathematical boundary condition keeping physical reality from collapsing.
The universal fluid is stable because its resonant geometry is locked to the critical line.
That completely reframes the nature of mathematics entirely. Math isn't just a language we invented to describe the universe.
The math is the physical structure. The distribution of primes is the acoustic blueprint of hydrogen.
And this acoustic resonance allows us to calculate the foundational pulse of gravity, right? The SDMT graviton.
Yes, in the standard model, the graviton is a hypothetical massless particle that supposedly transmits the force of gravity.
But no one has ever found one.
In SDMT, the graviton is not a particle at all. It is the lowest possible vibration of the fluid grid.
The lowest non-zero eigenvalue, the fundamental mass gap.
When you calculate the base frequency of the L39 operator across the grid, it yields an acoustic rhythm of exactly 1 hertz.
1 cycle per second.
Gravity beats exactly once per second.
It's an acoustic fractal rhythm pulsing through the hydrogen ocean.
And this rhythm is mathematically locked in by what is known as a Berry phase condition.
Okay, let's unpack that. A Berry phase describes how a system acquires a geometric phase shift over the course of a cyclic adiabatic evolution.
We should return to our topology to explain this clearly.
Good idea.
If you walk around a standard 2D circle, you end up exactly where you started, in the same orientation. Your phase shift is zero.
Makes sense.
But the universe is a non-orientable Klein bottle, structurally built like a 3D Mobius strip.
Right, and if you walk one full loop around a Mobius strip, you end up in the exact same physical location, but you are upside down.
You have acquired a geometric phase shift. To return to your original orientation, you have to walk around the loop a second time.
So any wave traveling through the plenum must complete a double loop to maintain perfect structural harmony.
Precisely. In the SDMT model, the Mandelbrot-Julia oscillation, the jitterbug cycle, requires exactly 39 discrete structural steps along the principal axis to accumulate the correct geometric phase to close the double loop without tearing the fluid.
And the math proves that to perfectly complete this double loop across a 39-step grid, the scaling dilation factor must be the square root of 137.
Which brings us full circle back to beta.
The scaling constant isn't an arbitrary number.
It is the only mathematical solution that allows a wave to travel around a pixelated Mobius strip and perfectly reconnect with itself.
The geometry dictates the math dictates the frequency, and the frequency dictates the physical reality.
It is an airtight, self-referential system. However, we have to address the final pillar of particle physics.
Mass.
Right. We've explained gravity without dark energy and matter without antimatter. But if space is just a fluid and there is no standard gravity, what gives an electron or a quark its mass?
The origin of mass. This is where SDMT completely dismantles the Higgs mechanism.
The standard model relies on the Higgs field to grant mass to elementary particles.
The analogy often used is that the universe is filled with an invisible field resembling thick molasses.
Some particles, like the top quark, interact heavily with this molasses, experiencing high drag, which we measure as high mass.
While other particles, like the electron, interact very little, slipping through easily, and thus have low mass.
It is a functional model, but it is deeply unsatisfying structurally because it relies entirely on tuning.
You have to manually dictate how strongly each particle couples with the Higgs molasses to make the math match the experiments.
The field itself doesn't explain why the top quark couples more strongly than the electron.
SDMT rejects the external Higgs field entirely. Mass does not come from an external substance imparting drag.
Mass is an emergent property of internal topological rigidity.
Let's follow the mechanics of a particle again. In SDMT, a particle is a stable pressure node, a localized vortex in the thixotropic fluid.
Its position on the fractal axis is defined by an index number, k.
An electron sits at a specific k index.
A muon, which behaves almost identically to an electron but is much heavier, sits at a higher k index further along the fractal axis.
So a particle's identity is just its address on the grid.
Exactly. But when the authors first attempted to calculate the mass differences between these nodes, they encountered what they called the scaling anomaly.
The initial approach was too simplistic.
They assumed an idealized, frictionless scale jump based purely on the constant beta.
The formula proposed that the mass ratio between two particles was simply beta raised to the power of the change in their k index.
Let's look at the numbers. An electron is positioned at k equals 18.00.
Yeah, okay.
A muon is located at k equals 20.17. The dimensional distance between them, the change in k, is 2.17.
If you take beta, which is roughly 11.653, and raise it to the power of 2.17, the resulting mass ratio is approximately 297.
The theory predicted a muon should be 297 times heavier than an electron.
But experimental data from particle colliders tells us a muon is exactly 206.8 times heavier than an electron.
The initial formula missed the reality by a factor of about 1.44.
And in theoretical physics, being off by that wide a margin usually means the entire model is fatally flawed.
But Dumont recognized that the initial equation ignored the physical properties of the plenum.
They treated the fractal grid as an abstract math concept, forgetting that it is a physical thixotropic fluid.
You cannot simply teleport a vortex from the electron scale up to the muon scale. The vortex must physically traverse the lattice.
This realization led to the corrected topological mass equation.
And crucially, they didn't just invent a fudge factor to close the 1.44 gap. They applied the geometric rules they had already established.
The correction involved two vital physical mechanics. The first is striction work.
We established earlier that gamma, the temporal viscosity, dictates a 17.2% energy loss during structural transitions.
Right. To shift from an electron scale to a muon scale, the vortex must perform physical work against that viscosity.
It must actively fight the thixotropic rigidity of the fluid to reform the lattice.
So the mass appears higher because the vortex is literally exhausting energy to overcome the friction of space.
The mathematical factor for this exertion is 1 plus gamma.
The second correction accounts for the geometry of the jump itself. It is the Klein-Bottle curvature factor, denoted by C.
This requires visualizing the bottleneck of the geometry.
Let's imagine the vortex is a highly pressurized water balloon.
Okay, good visual.
When it jumps from the electron scale to the muon scale, it isn't moving through a straight tunnel.
Because the universe is a closed Klein bottle built on a triple-axis golden cross, the pathways feature 90-degree topological twists.
The striction neck, the fundamental torsion of the geometry.
Squeezing that highly pressurized water balloon through a sharp 90-degree twist takes immense energy.
The ambient fluid resists the deformation. As the vortex contorts to fit through the bottleneck, potential energy gets stored in the surface tension of the thixotropic plenum itself.
The sheer physical resistance it faces, and the energy required to bend through the torsion, fundamentally alters its effective mass once it emerges on the other side.
That analogy aligns beautifully with the topological cutaway diagrams in the source material.
As the vortex squeezes through the torsion bottleneck, the stored energy reduces the effective scale jump.
Mathematically, navigating a 90-degree geometric twist introduces a curvature factor equal to 1 over the square root of 2.
Which is approximately 0.707. Again, this isn't a free parameter. It is the absolute trigonometric result of a right-angle torsion.
So we have the original jump distance, modified by the friction of gamma, and modified by the geometric squeeze of C.
Let's trace the final deduction. The dimensional distance for a muon is 2.17.
We multiply that by the striction work, 1 plus 0.172.
That gives you the total energy required to overcome the friction. But then we must apply the curvature factor, multiplying by 0.707 to account for the energy stored in the torsion bottleneck.
The result of that modification alters the effective change in the K-index to approximately 1.796.
And when you apply the base formula taking beta, 11.653, and raising it to the power of 1.796, the resulting mass ratio is exactly 206.5.
The measured reality is 206.8.
A stunning, practically perfect match without tuning a single dial.
The 1.44 anomaly entirely vanishes simply by respecting the physical geometry of the fluid.
And this parameter-free precision extends up the ladder of elementary particles.
Like the tau particle.
Yes, the tau particle represents an even larger scale jump from the electron with a change in K of 4.05.
When Dumont runs the exact same topological mass equation multiplying by the striction work and the curvature factor, the predicted mass ratio is roughly 334.70.
The actual mass ratio measured in collider experiments is 3.477.
The mathematical precision holds firmly across orders of magnitude.
They extended the framework to quarks as well, deriving their masses based on their integer or half-integer positional assignments on the Golden Cross.
For the top quark, the heaviest fundamental particle known to physics, its position index K sits at approximately 23.5.
When subjected to the topological mass equation, SDMT predicts a mass of approximately 173 giga-electronvolts over c squared.
Which perfectly aligns with the most advanced collider measurements of the top quark, sitting right around 173 GeV over c squared.
It is a profound triumph of geometric logic.
SDMT takes an equation containing 0 adjustable parameters, an equation built entirely from the square root of 137, the golden ratio, and the trigonometric reality of a Klein bottle,
and predicts the mass of fundamental particles with extreme precision.
It proves that mass is not an arbitrary value assigned by an invisible field.
Mass is a coupled structural resonance. It is the geometric friction of navigating the rigid topology of reality.
The explanatory power of this framework forces us to step back and reevaluate our place in the universe.
It really does. We began this deep dive picturing an empty, passive theater.
And we end it submerged in a fractal, thixotropic ocean of phase-locked hydrogen.
Where gravity is merely the acoustic pressure gradient of cavities rhythmically filling and unfilling.
Where the forward march of time is simply the 17.2% friction loss of reality restructuring its lattice.
And where the distinction between matter and antimatter dissolves into the continuous inhale and exhale of a fluid geometry.
For you listening at home trying to synthesize all of this, the real takeaway is the breathtaking elegance of a parameter-free universe.
We don't live in a messy, arbitrary construct governed by dozens of random numbers.
We live in a tightly bound, musically resonant, self-correcting geometry.
And that realization bridges a gap that physics rarely crosses. It makes the cold equations feel incredibly intimate.
We aren't just sitting in this space. The particles that comprise our bodies are rhythmic deformations of this space,
We are continuous topological expressions of the plenum.
which loops us back to that biological parallel you highlighted earlier involving the striction angle.
Yes, the 55.82 angle.
That is the thought I want to leave everyone with because it is the most haunting implication in the entire 2026 dataset.
The fundamental striction angle of the universe, the perfect resting equilibrium where a thixotropic shear of reality zeroes out, is phi sub c, which equals 55.17 degrees.
And we noted that the internal geometry of a water molecule is 110.34 degrees.
Making the universal striction angle exactly half the angle of H2O.
The paper explicitly hypothesizes that because of this perfect geometric mirroring, water acts as a primary transducer for the acoustic frequencies of the SDMT framework.
The implications of that are staggering.
The universe vibrates as a 1 Hz acoustic pressure wave across a hydrogen grid.
And the water molecule is geometrically perfectly tuned to intercept and resonate with that exact frequency.
It implies a structural tuning.
Exactly.
Consider the water inside your own brain, the water in your blood cells, the vast, deep oceans of our planet.
Are they acting as macroscopic acoustic antennas?
Are biological entities, which are composed primarily of water, physically and permanently tuned to the fundamental heartbeat of the cosmos?
It suggests that the emergence of consciousness in biology isn't some statistical accident in a random, empty void.
Life itself might be a mandatory resonant feature of the geometry.
The thixotropic fluid restructuring itself into awareness.
So the next time you hold a glass of water or feel the pulse in your wrist, consider the mechanics behind it.
You might not just be feeling the rhythm of your own heart.
You might be feeling the 1 Hz geometric pulse of a Thumb-9 cubed universe, echoing through the perfectly tuned transponder of your own biology.
It is a reality-altering thought to sit with.
And one we encourage you to deeply ponder long after this deep dive ends.